In this exercise, we'll be looking at a problem so-called the birthday paradox, where we have n people, and each person has a random birthday out of the 365 days. And the probability we want to measure is the probability of the event that no two birthdays coincide. To set up a problem, we'll define the sample space omega as the set of all possible birthday combinations. Let's see how big that is. Well, we have a collection of n people, and each person has 365 choices, and therefore the total number of choices for all possible birthday combinations will be this number raised to the power n. So this will be the size of our sample space, omega. Now, out of the sample space, we'll look at all choices, all combinations, where no two people have exactly the same birthday. To count that, we can start from the first person, person number 1. Well, this person has 365 choices because so far there has not been any other birthdays to be conflicting with. However, for the second person, we know that whatever the first person chose, we cannot choose the same birthday again. Hence, we're left with 364 choices. Keep going like this, we get 363, and so on and so forth, until we reach the last person, which will give us 365 minus n plus 1, since we've repeated this process n times. Now, looking at these two numbers, we know that the probability of no two birthdays coincide is equal to the size of the event, which is this product here, 365 times 364, so on and so forth, times 365 minus n plus 1, divided by the size of the sample space, 365 raised to the nth power. Now you might wonder, how big really is this probability? Well, this plot shows if we were to plot the probability of having no two birthdays coincide as a function of the size of the group, n, where n goes from 0 all the way to 80, we see that the probability drops very quickly. In particular, if we were to draw a line right here from having 50 chance of seeing no two birthdays coincide, we see that roughly around 23, we already are seeing a chance smaller than half. If the group size is about 40, the chance of having a unique birthday for everyone is only about 10%. Now here on the right, we are plotting the same probability, but with a different scaling. So on the y-axis, we're plotting with respect to a logarithmic scaling, showing a finer granularity of the value near 0. Now we can see right here, beyond 60, in the plot on the left that we saw before, you can barely tell the value Pn. So here, if we were to track 60 around right here, we see that the values start dipping below 1% and all the way till 10 to the negative 10th. So that's a tiny number, even though we only have a group of size 120.